One of the methods of converting this is called hydrogenation. And that's where the material is percolated, we'll call it that. It's a little more complex, at very high temperature and very high pressure, and is agitated with hydrogen gas, and then is condensed into a liquid. This is very similar to a standard cracking plant. Condensed into a liquid, and that liquid is referred to as bio-oil. If you want to look that up, the Department of Energy has a wonderful website. All of that information, NREL does also. All of that information is available, free. They're even pleased if you call them to talk to them about it. But anyway, that product is very similar in chemical and physical structure in terms of viscosity, lubricity, and cetane content to light sweet crude. Once again, this is a product that is highly adaptable to existing petro infrastructure, and it's most suitable, this process is most suitable where heat is available. One of the obvious ones is a coal-fired generating plant. One modification of this process uses what is called a mixed or stirred bed reactor system, uses particulate matter, usually silica sand, with high temperature and pressure, and the material is liquefied in that fashion. You have particulate matter and you have high pressure, high temperature gas at a coal-fired generating plant, which incidentally is all a problem for them. Now here's a situation where you can take one thing that's considered a waste, one thing that's considered a pollutant, put the two together and walk away with fuel. It's not quite that simple, but that's the basic idea. Depolymerization is another. That uses superheated water with pressure, and it's very suitable for complex carbon feedstocks like plastic bottles and paints and terpenes and FOGs with cleaning materials in them and paint and so on. It's a very effective process, to convert this to a bio-oil. Once again, the product is a petro-compatible bio-oil. Suitable, you could put it in a standard petroleum refinery, put it in a blending plant, and convert it to a fuel that meets ASTM standards. Pyrolysis is another process. It's an anaerobic heating. It's in the absence of oxygen. Takes it up to a very high temperature and produces a liquid bio-oil. One of the spin-offs of this is using plasma as a process, and the byproducts are char, a carbon char, where they're using tires, incidentally, as a feedstock, metals, glasses, silica, other types of melted byproduct that can be used for other processes. And it's very useful for cellulosic feedstocks, weeds, switchgrass. And one of the advantages, incidentally, that I didn't point out in this is that none of these processes utilizes a crop or utilizes a process or a substance that will affect food prices or food production. The processes, and I've jumped ahead a little bit, the hydrogenation-derived renewable diesel is close to full commercialization. It's been utilized in fact, Brazil, I think it's called Petrobras, is in commercial production, has been for years. There's one in Germany called Sun Diesel. They've been around for years. And we have one that is it's called Eco Refining, that's a trade name, and it's Honeywell Corporation that is behind this one, and it's using a modification of the hydrogenation process, but it's being road tested in the United States right now, principally in municipal buses. Now, Pete, you gave me a signal. Does that mean that you want me to run long and show my videos, or does that mean wrap it up? Oh, geez. You know, I don't get it. this is bigger than the town I come from. I don't get a chance like this very often. But I do enjoy talking about Greece. I know, I guess it's kind of like some folks who adopt orphans, they get great pleasure out of it. I have no children of my own, so we'll just call mine Greece. Any questions? Thank you very much.
One thing I was thinking as I was listening, obviously, I think we've come a long way in terms of public recognition of water shortages and whatnot, but fog is still a pretty new concept to the general public. Can you tell me a little bit about communicating, what you were talking about, not just to the engineers and people here, but to the wider general public?
Well, and that was why I was emphasizing compatibility. Wide-scale societal change is difficult. You might note that our keynote speaker talked about the problems. 4 decades. Still can't see any measurable progress. Very frustrating, I'm sure, and the man is tremendously dedicated, obviously. So if you think initially of adaptability to current behavior, current infrastructure, then you don't inherit that impediment. So if you look at great motivating factors, World War, for example, World War II, we had a situation in which we did save fat. We saved it for the glycerin, for the munitions production. But that took a tremendous effort. There were posters everywhere, there were economic incentives and so on. And yes, it was successful, but it was the peril was the motivator. I don't think we have peril to motivate yet, but we sure have inconvenience and we sure have hardship imposed by high fuel prices. And so I think that if you look at adaptability to the infrastructure, societal, economic, engineering, you probably have a higher opportunity for success. It still requires motivation and education, but you're not inheriting an insurmountable cliff of behavioral change.
Can this, your particular part of this industry kind of learn from where water has been? I mean, in terms of water conservation, is maybe, a couple of decades ahead in terms of that need or that threat being there. Is that something you can look to their example and take that?
Well, I think so. Since sanitary sewer overflows is considered by the U.S. EPA as the largest single jeopardy to our freshwater supplies and our fisheries. And we're having $24 billion per year expenses cleaning these up. If we can prevent those and motivate folks to harvest fog and make money doing it and produce fuel and decrease our foreign dependence on fuel, at the same time protecting our water supplies, there's no dichotomy there in terms of goals. And I represent a company that's been in that business for 85 years. And so, that's kind of a given with J.R. Smith Manufacturing.
Can you just give me just a comment on an event like this in general and being able to speak with this audience about an emerging technology like this?
It's tremendous. I mean, I first got involved with this, and I must say that I nearly missed the opportunity of being involved. And I have some friends that are with IAPMO, and they kind of prompted me that this might be something I'd be interested in. So I did attend one simply because I was in the area at the time. I am very glad that I did. I've been participating in it ever since. Absolutely. Emerging technologies, especially you notice we had a lot of speakers from England and Australia and so on. That is tremendously helpful. We're not the only folks on the planet, and others are facing water issues, and we can learn from each other. And in terms of water conservation, I think that certainly Australia and Israel are pioneers. We can help one another. And so, yes, this is an excellent opportunity.